Hello. In this video, I'm going to demonstrate the problems worked in the example paper for the Week 5 discussion board in MAT221, Introduction to Algebra. This first example has 4 terms in it, 1, 2, 3, 4. And usually when confronted with a problem that has 4 terms, the first thing that we want to consider is a method called factoring by grouping. So we're going to consider the first pair of terms and the second pair of terms separately, and then see what we can do from there. The first pair of terms has a common x squared. So I'm going to factor out that x squared, and that leaves x minus 2. Now here's where a little strategic thinking comes in handy, because we need to think of this positive 18 as a double negative. Let's change that plus back to 2 negative signs, because now I can see that not only do 9x and 18 have a common factor of 9, they each have a negative that I can pull out. So if I pull out that negative 9, that leaves x, one of these negatives, and 2. Now this was strategic because we can now see that each of these 2 new larger terms has a common x minus 2, which I can now factor out, and that leaves x squared minus 9. Since I did one arrow, I might as well do both. Well, as it turns out, we're not quite done factoring yet. This second factor, x squared minus 9, is called the difference of squares. So I can factor that one more time as x in both of these parentheses. X times x is x squared. 3 times 3 is 9. And then if I alternate signs, I get that middle term in the FOIL process. We looked at FOIL in Unit 4. So the difference of squares always factors as the sum and difference of the same 2 terms. Now my next example is again going to involve removing a common factor. You see there's 6w squared minus 12w, which is 6 times 2, minus 18, which is 6 times 3. So I can factor out a 6, and that leaves w squared minus 2w minus 3. Now we're going to undo the FOIL process for this polynomial that remains inside the parentheses. We're undoing FOIL, so we know we've got to have 2 sets of parentheses. W times w makes w squared. 3 is pretty easy to break apart into factors. It's just 3 times 1. So now we just need to get the signs correct so that this middle term comes out correct. So if I have minus 3 plus 1, that makes sure that I get to negative 2w as the middle term. Got another problem sheet made up for our other examples. So here's one at the top. It looks similar to that other one because I've got 8 VW squared plus 32 VW. 32 is 8 times 4. Plus 32V. And again, 32, 8 times 4. So each of these has a common 8. But you can also see that each has a common v. So let's take out the 8v, and that leaves w squared plus 4w plus 4. Now we saw in our first example, an example of what's called the difference of squares. What remains inside this set of parentheses is a polynomial referred to as a perfect square. And perfect squares factor as the product of two identical binomials. W times w is w squared. That gets our first term, you see. 2 times 2 gives us our last term, 4, and all the signs are the same. So this is called the perfect square because this can be simplified as w plus 2 squared. It's a binomial squared. So this is the perfect square. And this is how it factors. All right. Our next example, minus 3y cubed plus 6y squared minus 3y. You know, by now, after the first several examples, we can see that, you know, these have a common factor of negative 3y. I want to take out the negative 3y because we like our first term typically to be positive, to have a positive coefficient. If I take the negative 3y from here, again, think of this as being two negatives. So I've got negative 2y left. And if I take this negative away, then I'm left with plus 1. This again is a perfect square. Let's take a look. Minus 3y. Y times y gives us this y squared. 1 times 1 gives us this 1. And if these are both negative, then I have y minus 1 times y minus 1. So I can simplify this as negative 3y times y minus 1 squared. So again, this is the perfect square, and it factors as the square of a binomial. Two more examples to go. The first one has no common factors. We're going to use what's called the AC method here. And in the AC method, we're going to look at A, which is typically the letter used to represent the first coefficient, and C, which is the last term. So I've got 5 times 6, which is 30. And the process with the AC method is we want to examine factors of 30 that add up to 13. Well, 10 plus 3 is 13. I want negative 13, so I'm going to make this negative 10 plus negative 3. And that gives me my negative 13b in the middle. So here's where some more strategic thinking comes in. Let's separate that 13 into negative 10b minus 3b. The first and last terms remain the same. Now we've got 4 terms. And I pointed to a situation in our first example where typically, if we have 4 terms, we're going to approach this by factoring by grouping. So I'm going to take out, you can see this first pair. They have a common 5b. So that leaves me with b minus 2. Now let's think of this negative 6 as having the double negative, this positive 6 as being a double negative. So if I take out minus 3, that leaves me with b minus 2. And this is important because now these two binomials match, which means I can take this one step further and factor out that common b minus 2. And that leaves 5b and negative 3 as the completion of our factoring for that problem. You can also do this by what's called trial and error. You could just guess and check over and over again these multiple combinations of coefficients, but in this case the AC method worked out to our advantage. One last problem, and this again has 4 terms, so that's really imploring us to approach this by factoring by grouping. The first pair has a common 3x. That leaves x minus 2. The second pair has a common 7. So that leaves x minus 2. So now we can take out these common x minus 2's. And that leaves 3x plus 7. Well, I hope these demonstrations have helped. These again are the exact problems demonstrated in the example paper for the week 5 discussion in Math 221. If you continue to have questions or are challenged by any of this material, please see the tutors or contact your instructor. Thank you.